Hey guys, this is Mr. Chang. This is my lesson video on lesson 3.1 from my textbook. The lesson is titled The Derivative of a Function, and it's a continuation of what we did in lesson 2.4 and also from lesson 2.1 as well. Okay, and then what we should know by now is the difference quotient formula and also the limits of that as h goes to 0, which will help us find the instantaneous rate of change or the slope of the tangent line at x equals a. When this limit exists, this limit is called the derivative of f at x equals a. Okay, that a value would replace our x value. In this section, we investigate the derivative as a function, meaning that we're more concerned with the expression, the actual expression of the derivative, as opposed to the number value for the derivative at a particular point. Okay, so here's the definition of the derivative, and then there's also an alternate form of the definition of the derivative, which is basically your slope formula, rise over run, and the quantities x and a has to do with the x values of these 2 points. And for our alternate formula, we're assuming that the point Q converges with point P, so that you're ultimately finding that that secant line that crosses those 2 points becomes a tangent line at a point, one single point. So let's go ahead and apply these two examples, these two definitions, these two formulas into our example 1, where we have to differentiate. Okay, differentiate is a word that substitutes finding the derivative for f of x. In this case, f of x is defined to be x to the third power, but we're going to use both forms of the definition of the derivative. So in this first video, let me use the old definition, which is to find the limit as h approaches 0 of the difference quotient formula, which is f of x plus h minus f of x all over h. And then let's go ahead and substitute x plus h and x into our given function. So we're still finding the limit as h goes to 0, but f of x plus h could be rewritten as the x plus h to the third power minus the f of x. F of x could be rewritten as x to the third power. Just substitute f of x for x to the third power all over h. We still can't do anything about the fact that h is approaching 0. It's not like we could plug in 0 for h at the moment. So we have to somehow simplify our numerator over here, okay, by just algebraically, okay, algebraic manipulation. So let me zoom this in a little more. And x plus h to the third power just means that I'm multiplying x plus h by itself 3 times. X plus h times x plus h times x plus h. It does not mean it's going to be x to the third power plus h to the third power. That's a common misconception. Okay, and then to simplify this part, the product, okay, of the 3x plus h factors. So what you would do, I will go ahead and multiply the first two factors first, x plus h multiplied by x plus h, which gives me, let me do this work on the side right here. So that gives me x squared plus 2hx plus h squared. And then in turn, that's going to be multiplied by x plus h, which means a lot of distributions will be occurring. So you got the x squared times x, which gives you x to the third power. And then you have x squared times x squared, then times h, which gives you x squared h. Then you got, okay, let me use a different highlighter here. You got 2hx times x, and then 2hx times h. That will give you 2x squared h plus 2xh squared, plus then you have h squared times x followed by h squared multiplied by h. So that gives me x h squared plus h to the third power. So what I did is I'm just trying to simplify this portion of my difference quotient formula. And in turn, I end up with, looks like I have x to the third power plus adding the like terms, combining the like terms, 3x squared h plus 3xh squared plus h to the third power, and then followed by that minus x to the third power at the end. So this whole thing minus x to the third power all over h. Again, we're evaluating the limit of this as h approaches 0. But as you could see on the numerator, you could cancel out the x to the third powers, and then you could simplify this more because all of the terms on the top are divisible by h. So you end up with 3x squared plus 3xh plus h squared. Okay, notice that this is, notice that this is divisible by h, that's divisible by h, and this is also divisible by h. Okay, and then we're still finding the limit of this as h goes to 0. And then now, as you can see, when the h approaches 0, it's going to be pretty much, you could treat h to be 0 at this point because h value of 0 would be defined in this expression. The answer will be defined with h being 0. So in this case, your final answer will be 3x squared, and that represents the derivative, what we call the derivative of the original function x to the third power. And on my next video, we'll use an alternate form of the definition of the derivative to find the derivative.